All right, so the example of creating our mock, right? It was somewhat needlessly complicated, right? Because it looks like we might have chosen the wrong, byte implementation for the input and output, right? It needed us to know how to work with byte arrays and how to convert back to strings and go back and forth between byte arrays and strings. So let's choose other implementation that might make this a little cleaner, right? A little more readable, a little more understandable. And the problem that we were running into is mostly because we're using these the original streams, right? The input streams and the output stream, in particular system.in and system.out. These streams are fairly powerful, right? And they have all sorts of behaviors that we don't really care about. We don't really need. These streams that we're using, that we chose, they know how to write to a network. They know how to write to a file system. They know how to do all sorts of implementation that we don't really care about, right? We just want to replace human input and human output, right? It's just characters. We want to just do strings, right? In memory even, right? That we don't really want to go out to a network or a file system or database or anything like that. So instead of using this very powerful set of implementation that we chose, let's use another one that is a little more general. Interfaces that are a little more general. They don't necessarily deal with any specific way of dealing with any particular stream, right? They don't deal specifically with files or deal necessarily specifically with networks. They just know that there's some characters and bytes that are just going from one place to another, right? Something that is much general. So instead of using the byte array input stream and byte array output stream, we're going to use these more general interfaces called the readable and the appendable interfaces, right? These are much more generic interfaces, way up in the hierarchy of interfaces. And let's see if we can rewrite our streams so that they're a little bit more readable. So instead of using our input stream and our print writer, instead we're going to be using interfaces that are hierarchically higher in the interface hierarchy, right? So we have readable and appendable. Presumably, the input stream somehow inherits from readable, and the print writer inherits from appendable, right? And because they inherit, this should still work, right? System.in and system.out are part of that same hierarchy. Make sense? We just went with a higher implementation, up or higher in the inheritance chain, right? So this controller rewriting this implementation. It's still implementing the same interface, right? But instead of using this more specific implementation, we're going to be using a higher level implementation, readable and appendable, and we're setting it to our in and our out to these two particular readables and appendables, right? Once we do that, we do realize that perhaps being up higher in the chain of inheritance, it turns out that in the documentation we realize that these interfaces, since they don't quite know what the implementation is going to be, they're a little more wary of limiting the ways that it can be used, and so they might throw exceptions at whether I/O exceptions that might occur. And you just have to be careful to catch these exceptions, right? I might throw this exception. I don't know if a particular implementation actually throws that exception, but just to cover myself, I'm going to throw that exception. So we just added here a throws I/O exception because we know our in and our out, our readable and appendable, could throw those exceptions. So we're covering our bases here and throwing that I/O exception. We're just passing it along. We'll need to, so this is the same implementation, right? Because we throw I/O exception, main also needs to take care of this exception, right? If you remember, main only just called the controller all by itself. Here, because the interfaces that we're using here might throw these exceptions, we need to put it inside of a try catch. So here it is. We're catching any exceptions that might be thrown. In particular, this I/O exception that could be thrown by these higher level interfaces. Yes. So now, because we're using this reader and appendable, right? We could use some common string related implementations such as string reader and string buffer that allow you to deal with streams, right? And this looks so much easier to read, right? For instance, here's reader in that just uses a string reader, right? That allows it to just provide a string, right? And it converts it into a stream in. And same thing for the out, just creating here an empty buffer, right? That presumably the calculator is going to write to, right? It's going to write the result in there. And so notice that this is so much more unencumbered, right? This is so much nicer. We're not dealing with arrays and bytes and converting back and forth, right? So it's just choosing a higher level implementation makes it so much easier to read. Yes. So this is somewhat more understandable and easier to write our tests. Right. Our tests are so much cleaner now. Right? Yes. It is. The string buffer adds a new line at the end. Yeah. We just need to be aware of that. Yeah. Automatically. Yep.